So question 1 was pretty straightforward. Just distributed the negative and added like terms. Question 2, the graph above shows the positions of Paul and Mark during the race. Paul and Mark each ran at a constant rate, and Mark was given a head start to shorten the distance he needed to run. Paul finished the race in 6 seconds. Okay? Mark finished the race in 10 seconds. According to the graph, Mark was given a head start of how many yards? How many yards? 18. Yep. Right there, the magic number 18, halfway between 24 and 12. Question 3, snow fell on a Saturday, of course. Oh, come on, that was good stuff. Seriously, where were you? Oh, man. And then stopped for a time. When the snow began to fall again, it fell at a faster rate than it had initially. Assuming none of the snow melted during the time indicated, it's not around here evidently, which of the following graphs could model the total accumulation of snow versus time? Snow began to fall, fell faster than it had initially. Well, it's definitely not at a constant rate. Assuming it began to fall, it fell at a faster rate than it had initially. Well, that almost sounds like, oh, I gotta pay attention. It stopped for a time. Duh. Okay. That's A, isn't it? Yeah, duh. Yeah, if you don't pay attention, it is. It did. A calculator got you through it. Oh, man, that is special. Okay, a website hosting service charges businesses a one-time setup fee of $350 plus $D for each month. If a business owner paid $1,010 for the first 12 months, what is the value of D? So 12D plus 350. So we subtract, right? What do we got there? Is that 760? 660, that makes sense. If we subtract that to the other side. Yep, that makes a lot of sense. And then divide out the 12. So is that 55? Yeah. Yes. Very nice. Which of the following inequalities is equivalent to the inequality above? They keep x and y on the same side. What's the common value that you can get rid of from all three of these numbers or terms? You could divide by 3, giving us 2x minus 3y is greater than 4. Is there anything like that? Yes! Where do people get most of their medical information? Okay. Do you really think it's not the internet now? I think it's going to be a higher amount on the internet than doctor. 63% seems really high. We believe a lot on the internet. The table above shows a summary of 1,200 responses to a survey question. Based on the table, how many of those surveyed get most of their medical information from either a doctor or the internet? So 1,200 times what? 0.76. Well, it's got to be more than 900, right? Because that would be 75%. But it can't be too much higher, so it's got to be one of those two. So let's see here. 0.06. No. I just want 0.1. That'd be 12. Yeah, there we go. Members of the city council wanted to assess the opinions of all city residents about converting an open field into a dog park. The council surveyed a sample of 500 city residents who own dogs. Okay. The survey showed that a majority of those sampled were in favor of the dog park. Really? Which of the following is true about the City Council's survey? It shows that the majority of city residents are in favor. The survey sample should have included more residents who are dog owners. Now, the survey sample should have consisted entirely of residents who do not own dogs. No, that's not true. The survey sample is biased because it is not representative of all of the city residents. Ding, ding, ding. You can't make conclusions about things when you do not do things randomly. The table above shows the flavors of ice cream with the toppings chosen by the people at a party. Each person chose one flavor of ice cream and one topping of the following of the people who chose vanilla ice cream. So they are limiting me to that column. So that's 13 total people. What fraction chose hot fudge? So they limited me. The total area of a coastal city is 92.1 square miles. Oh, incidentally, the Australian fires.
Oh, I heard about that from a YouTuber.
Oh, really? From a YouTuber. Okay. So I figured out that it's larger than the state of Indiana. It's larger than the state of Indiana by about 25%. It's significant, you know. Total area of a coastal city is 92.1 square miles, of which 11.3 square miles is water. Okay? I wonder if people live there. If the city had a population of 621,000 people in the year 2010, which of the following is closest to the population density in people per square mile? So 62, what are we going to be dividing this by? Is it 92.1? Minus the 11.3, right? We're assuming that those people, people could live on the water, right? There are houseboats. Now, since several people have stolen my calculators, I cannot answer this question. What do you got? 460. Did you put parentheses around that when you divided it? Please tell me yes. What? B? Do we have another one on B? Does anybody else? B? Yes. Close enough. Question 10. Between 1947 and 1500, Amerigo Vespucci. That's a great name. Embarked on 2 voyages to the New World. According to Vespucci's letters, the first voyage lasted 43 days longer than the second one. Let's walk out. And the 2 voyages combined, the 2 voyages combined lasted a total of 1,003 days. Wow, there you go, that's a long trip. The first voyage was 43 days longer than the second, so the second was shorter. So we have to take the shorter one and add 43 days to get the longer one. Okay, sounds like a job for substitution, really. Is that what you guys did? Alright. So if I substitute that in, I get 2y plus 43 equals 1,003. Subtracting 43 to the other side would give me 960 equals 2y. So the shorter trip was 480. Is that what they asked me for? They asked me. The first voyage lasted 43 days long. Well, I just wanted to make sure I was answering the question right, because if they asked me about the other one, then I'd be wrong. Yes, and check.
I just said 1003 minus 43 divided by 2. 480 plus 480 plus 43 equals 1,003.
I guess you could just cut it in half and then just kind of figure out the value from there.
Yeah, we do. If you do 103 minus 43
that what I did?
Yeah, but I just did it in this
Oh.
little, I didn't write any work.
Oh, yes. I'm so proud. But, hey, this is about speed, so I do understand what you're getting at there. If the process, if in your mind you could say, okay, take off the 43 days, cut it in half. Yeah, it's the same thing. Good. For the solution, make sure I unpause that. Okay, good. For the solution to the system of equations above, what is the value of x minus y? Okay, I thought we could do something cool here, but I don't think I can. I think I just have to brute force this. 13x equals 13, so now we know that x is 1. Did you have a different strategy?
I just think it's not easy.
Well, what I was trying to do is I was trying to subtract the two equations to see if there was a way that it would spit out x minus y and I could go right to the number. But it doesn't work. Not the way I wanted it to. So 6 times 1 minus 3y equals 5. Subtract 6 to the other side, negative 3y equals negative 1, so y is positive 1/3. So if we want 1 take away 1/3, what do we get? Because that's x minus y. I got 2/3. Okay, so we got sunflower height over time. Starts out strong. I guess it starts out decent, and then it grows faster in the middle, and then it really slows down at the end. Okay. In 1919, H.S. Reed and R.H. Holland published a paper on the growth of sunflowers. Nice to know. Included in the paper were the table and graph above, which show some of that stuff. Obviously, we can pass through quickly. Over which of the following time periods is the average growth rate of the sunflower least? So we're looking for something that has the shallowest slope. And it's got to be towards the end. Isn't it 63 to 84? Yeah, it has to be. Because that's the end of the number of days. The function defined where a and b are constants models the height in centimeters of the sunflower after t days of growth during a time period in which the growth is approximately linear. What does a represent? That would be the slope. So that would be the rise or the change in height. Here, we'll do this. Some cool physics stuff. Change in height over change in time. Okay, do we have any answers that look like that? Change in height over change in time. The predicted height in centimeters of predicted height in centimeters of sunflowers at the beginning of the period. That would be the y-intercept. Predicted height in centimeters of sunflower at the end of the period? No. Predicted total increase of the height during the period? No. One of the dead giveaways is right here. Each day. Change in height each day, because that represents the per time change. Okay, growth of the sunflower from day 14 to day 35 is nearly constant. On this interval, which of the following equations best models the height in centimeters of the sunflower t days after it begins to grow? So 14 to 35. 14 to 35. Okay. So from 14 to 35. Now obviously I'm going to have a negative y-intercept on that path. The slope looks like I'm going up. Okay, I'm going to guess here that I'm going from 70 to 100. There's a 30-point spread there, and then I'm going 7 over 30 divided by 7 is going to get me a little bit over 4. Okay, so it has to have a negative y-intercept and something over 4. So, hey. That would be... Any other ideas on making that a faster process? Okay. So did you actually plug in, did you like find a slope and a y-intercept? Okay. So did you estimate like this? Did you draw a line and see that it was going to be a negative y-intercept? Okay, that's what I would have done. I would have calculated the slope, ran a line through it, and knew that it was a negative. Okay, so you could do that too. Yeah, you could. The reason I did what I did is because I was just trying to count on the page, just to try to make it quicker. But yeah, you could do what you were suggesting. Use both the coordinates. That's kind of what they would force you to do in Algebra 1, because they would want you to find the slope between these 2 points. But if we can count faster, I think that'd be the best. Which of the following equations relates y to x and the value? Okay, so let's see what we have here. Are we going up by the same amount every time? We are, aren't we? If we're going up by the same amount every time, isn't that linear? Okay, so it cannot be exponential. How much is it going up by each time? Every time I go from one to the next, what am I going up by? Isn't it 14 over 4? Top's going up by 14. Obviously, the bottom does not change. Okay, so that is what? What fraction is that? 7 over 2. Ding, 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 ding. There's your slope. Can you plug in values? Yes, you can. Yes, you can. But I would like you to see that it's got to be linear. So at least you could get down to the linear choices and then plug in values. That's a good option. And if you flat out don't know whether it's linear or exponential, you could do that strategy of plugging in values. You're right. In the triangles ABC and DEF are shown, which of the following is equal to the ratio BC over AB? Okay, so I'm going to rearrange this triangle right here into a triangle that looks kind of like the other one. So E would be over here, D would be at the top, and F would be here. So they want me to compare BC to AB. So we will want DF on top and DE on the bottom. DF and DE. Okay, so when we build staircases, we have what's called the riser height and the tread depth. Okay, if the riser height, like if you go to a stadium, okay, typically the tread depth is not very big and the riser height is. That's how it looks. I don't know if you go to, if you've been to Banker's Life. Is it still called Banker's Life Fieldhouse down in Indianapolis? Okay. If you've ever walked into there, first of all, when you look at the outside of the building, you think, how is this a stadium? That's what my first thought was when I saw it. I was like, how is this a stadium? And then you walk inside and realize they dug a giant hole in the ground, right? So when you walk in, you're at, like toward the top. And you're kind of like, whoa, this is weird. And then you're like, whoa. And yes, it goes steep. And that's, you don't want that in a house, okay? We don't want people falling down the stairs. Honestly, I don't think they want that at an arena either, but they still make them pretty steep sometimes. An architect can use the riser tread formula 2h plus d equals 25, where h is the riser height in inches and d is the tread depth in inches. For any given stairway, the riser heights are the same and the tread depths are the same. We really hope so. That's true. The number of steps in a stairway is the number of its risers. Okay, so the number of risers is the number of steps that you have. For example, there are 5 steps in a stairway in the figure above. Because we have the 1, 2, 3, 4, 5 risers. So that gives you the number of steps. And the total rise of the stairwell is the sum of the riser heights as shown. Okay. Which of the following expresses the riser height? So expresses the riser height. What does that mean? What do they want me to do? They want me to rewrite the equation 2h plus d equals 25 and solve for what? Probably h, right? Because all the answer choices are solved for h. Okay? So we can subtract the d's from both sides. We got 2h equals 25 minus d. But I don't see an answer choice that looks like this. Do you? Ah, right there it is. Division is the same as multiplication by the reciprocal. Just like we taught you back in middle school. Sometimes they disguise their correct answers with a little handy-dandy algebra. Some building codes require that for indoor stairs, the tread depth must be at least 9 inches, and the riser height must be at least 5 inches. According to the riser tread formula, which of the following inequalities represents the set of all possible values for the riser height? Okay. Now, does it make sense that it says here, according to the riser tread, which of the following inequalities represents the set of all possible for the riser height? Well, okay. It says that it has to have a minimum of 5. How in the world could it be less than 5? And how in the world could it start? How in the world could it start at 8? Now, I'm not going to completely rule out letter D, because maybe when I look at the formula, maybe I'm going to see something that I didn't see before. But, I don't know. Let's see here. We said that h equals 1/2 25 minus d. Let's say I plug a 9 in there. Okay, so that would be the minimum tread depth. The minimum tread depth. Okay, so what do we get if we do that? We get 8, don't we? So the minimum tread depth would cause my height to start out at 8. Is that bigger than 5? Sure. Because it says that the tread depth must be at least 9 inches. It could be more than that. I'm thinking I have to go with D, but why are we capping it off at 16? If we had 16, what would that mean? H equals 1/2 25 minus D equals 16. So that would be 3225 minus D equals 32. That does not make sense, does it? Am I seeing that right? I double both sides and I get 32. That would make my depth -7. That does not make sense, does it? So there's no way it's almost as if that 8 is a maximum, not a minimum. I'm thinking the answer is C. We'll come back to this one because I want to verify that. But it does happen. The height does have to have a max. You know, the tread depth was 25, would be in some trouble. Yep.
But it has to be at least 9. There's no way that it can be 8.
Right. So let me rethink this. I'm going to come back to this when you guys take a break here in a second. After we get through 19, I'm going to come back to this one, rethink this one, because I agree with you. Something doesn't seem right there. An architect wants to use the riser tread formula to design a stairway with a total rise of 9 feet. Okay, a riser height between 7 and 8 inches, and an odd number of steps. Okay, with the architect's constraints, which of the following must be the tread depth in inches of the stairway? Okay, so we have a total of 9 feet. That would be all the riser heights added together. We have an odd number of steps. Okay, so if the riser height was 7 inches, okay, so let's see, 9 feet. 9 feet is how many inches? 9 times 12? Is that 108? So we have 108 inches. If we had that in 7 steps, 7 riser heights, that's not a good number, is it? Because we said the number of riser steps is equal to the number of steps. Yeah, that's giant, isn't it? Am I way off there? That's... Yeah, that's... We don't want to step more than a foot. I don't know. I'm thinking through this one. So, take a break, and I'm going to think through this, and I'm going to nail down a good solution for us, because I don't... I think it's best if we use this formula right here. Okay. Where's my work for that one? Okay, so if we go with 2 times h plus 9 equals 25, what's the solution to that? Now this is assuming the smallest tread depth, which would be the most number of steps. Well, that would depend more on the riser height. Okay. So what does h have to be? That would force it to be 8. Now we know that the minimum for the height is 5. This fixes it, I believe. If we go with a larger number, 2h plus 10 equals 25, then 2h equals 15, h equals 7.5. Do you see how the number's getting smaller? Has to be between 5 and 8. So we were right on that one. Okay, 19. So, figured out there's 108 inches to cover in this total rise. If we do 108 divided by 7, we find out that there would be 15.42 steps. These are steps. Okay? Not inches for the steps, okay? Because that would be a giant step, right? If we change that to 108 divided by 8, right, because they said we could go between 7 and 8 for the riser, we get 13 and a half. Now, it says right here that we want an odd number of steps. What is the only odd number between 13.5 and 15.42? 15 steps. So we just locked ourselves into 15 steps. Now, if you take that 108 and you divide by 15 steps, what is the riser height? That is 7.2. Please do not choose 7.2. They did not ask you about the riser height. They asked you about the tread depth. So this is the riser height. What am I going to do with that to figure out the tread depth? Can't we use that formula? 2 times 7.2 plus D equals 25. And if we do, we will get the correct answer of 10.6. Now, another thought you could do that might help you, but is not necessary. What if you assumed that the riser height was 7, and then also checked for 8? Now, what happens when you do this is that you end up finding that the tread depth has to be between 11 and 9. Now, that would only get rid of 2 choices off your list. So, it would be a better thing than not knowing what to do at all. But yeah, this is a significantly challenging process to think through. Once you do, okay, but that would be a tough one. Alright, I'm going to give you about 10 minutes to do as much as you can. So 10 minutes, and then we'll get started on these questions. Okay. This is some of the solutions to this. Well, the solutions are 6 and negative 0.7 if you set each of these equal to 0 and solve. So the solution would have to be, the sum would have to be 5.3. Well, that's a heck of a lot easier than the architecture question. The study was done on the weights of different types of fish in a pond. A random sample of fish were caught and marked in order to ensure that none of them were weighed more than once. A sample contained 150 largemouth bass, of which 30% were weighed more than 2 pounds. Which of the following conclusions is best supported by the sample data? The majority of all fish in the pond weigh less than 2 pounds. The average weight of all the fish in the pond is approximately 2 pounds. Approximately 30% of all the fish in the pond weigh more than 2 pounds. So far, I'm leaning in these directions. Approximately 30% of all largemouth bass. Now, yeah, let's not get that one because this one just says fish. So that's going to take that out. It does have to be largemouth. Okay. Now, why is A bad one? Because it wasn't about all the fish. It was about only the largemouth bass. So, once again, yes. Okay, so let me back up and look at this again. A random sample of fish were caught. Okay, so it could contain other things besides that would make sense. The sample contained 150 largemouth bass, of which 30% weighed more than 2 pounds. Which of the following conclusions is best supported by the sample data?
So it kind of like makes it seem like all that was collected was like all largemouth bass.
Right, but I think it's true that they probably got more than largemouth bass.
That doesn't say that.
Right. So what I'm getting at is they only weighed the largemouth bass. So they might have gotten samples of other things, but they didn't tell us about it. So that's why I'm leaning towards D. What were you leaning towards? C, approximately 30% of all fish in the pond. Well, I don't know that. All they told me was the sample contained 150 largemouth bass. I'm sure there were more than that. Of those 150 largemouth bass, 30% weighed more than 2 pounds. So this 30% refers back to the largemouth bass. It does not refer to all the fish that they sampled. I'm pretty sure it would have to be D. It's valid to ask those questions, that's for sure. 2008, there were 21 states with 10 or more electoral votes, as shown in the table above. Based on the table, what was the median number of electoral votes for the 21 states? Okay, so if you've got 21 numbers written out in increasing order, where do you find the middle? If you've got 21 different numbers written out in increasing order, where do you find the middle? No, it's not. It's the median. So, don't you have to have 10 values, then 1 value in the middle, and then 10 more values? That would be 21 different numbers. So the truth of the matter is, whichever one is the 11th data value starting from the bottom, that's going to be your median. So we've got 4 of these 10s, we've got 4 of these 11s, that now we're up to 8th place. We got 9th place, we got 10th place, and guess what? Inside this group right here is the 11th one. It's a 15. A lot of people do not, they just start counting from the bottom, 10, 11, 12, 13, 14, 15, and they just start to try to find it that way instead of realizing frequency matters. Does that make sense? We got to take into consideration the frequency, otherwise we're going to get the wrong value. As a part of an experiment, a ball was dropped and allowed to bounce repeatedly off the ground until it came to rest. This is one of those geometric sequences. Actually, depends on the way they ask the question. It could be a sequence or a series. The graph above represents the relationship between the time elapsed after the ball was dropped and the height of the ball above the ground. After it was dropped, how many times was the ball at a height of 2 feet? Okay, at a height of 2 feet. Once, twice, 3 times. So, looks like it was only at a height of 2 feet for 3 times. That wasn't even they didn't even ask me to do something with the geometric sequence. Customer's monthly water bill was $75.74 due to a rate increase. Her monthly bill is now $79.86 to the nearest 10th of a percent. By what percent did the amount of the customer's water bill increase? New number minus old number over old number. This is what we taught you a long time ago. The new number is 79.86 minus 75.74. Some of you might say the difference or the change in. That's exactly the same thing. Over the old value. So what do we end up with there? Because once again, I don't. What? Can I get a witness on that? All right, the motion is passed. Question 25. Some values of the linear function are shown in the table above. What is the value of f of 3? Every time it goes up by 2, okay, so it goes up by 2 there, and that goes up by 6. When it goes up by 4, this goes up by 12. So is that, okay, it is a linear function. Duh, I should have read that. Okay, so slope of 3. Okay, so the slope is 3, and the y-intercept is negative 2. They told me that right there. So 3 times 3 minus 2, 7. Right, we got 6 over 2 for the slope just by looking at these two numbers right here. The y's went up by 6 when the x's went up by 2. And they gave me the y-intercept. How kind of them. A gear ratio R to S is the number. It's the ratio of the number of teeth of 2 connected gears. The ratio of the number of revolutions per minute of 2 gear wheels is S to R. Okay. In the diagram below, gear A is turned by a motor. The turning of gear A causes gear B and C to turn as well. Gear A is rotated by the motor at a rate of 100 revolutions per minute. Okay. So, my question, do we have a 20 to 60 to 10 ratio? So, if we spin this at 100 revolutions per minute, my question is, can we just multiply this by 5? That is not going to work, is it? No. Because 100 revolutions per minute okay, every time gear A goes around one time, or I guess maybe I should ask this question. How many times does gear A need to move to make the big one go around once? It has to go 3 times. When it goes 3 times, this one will travel 1 time. Okay? Now, every time this one travels around once, this one travels around how many times? 6 times, right? So if you take the first one and do 100 revolutions per minute, all right, let me think through that. Well, we divided, okay? 10 goes into 60. Yeah, it's a sixth of the size of the big one. The size of these gears is a little deceptive. I will say that too. Okay, so remind me what you did.
I just did, if one revolution of gear A is 20,
Okay,
and gear C is 10 per revolution.
so you compared this to the end.
Yeah,
Ah, yeah. So he just skipped the one in the middle altogether. Good idea. That is a good idea. So if you're doing 100 revolutions per minute, the other one would be 200. Yeah, that's nice. Well, because this one is a bigger gear, the other one's going to turn faster.
I just did it like so gear A is double the size of gear C. So then
I think it has everything to do with how they reversed it right there. When they said revolutions per minute, they reversed it. because this would have to go twice the speed since this is smaller. It would have, I'm in terms of revolutions per minute. In terms of teeth, it's the same. But okay. Question 27. In the XY plane, the graph. Make this our last one, I think. What is the radius of the circle? Okay, so for those of you who are not aware, you have probably seen this before, but you might not have talked about it like this. Well, you probably did in geometry a little bit, okay, but this is the Pythagorean theorem. A squared plus b squared equals c squared. Yes, it looks a little bit different because it's got x minus h and y minus k, but that's because this and this are the center of the circle. And over here, r is the radius, okay? So they need me to group the x's together. In fact, what they're going to be asking me to do here is completing the square. I know you guys hate that. And I'm going to have to leave some space there, and I ran out of room. I'll have to put my equals 45 on the other side. Okay. So I always use b squared over 4a when I complete the square. In the first one, I would have negative 6 squared over 4 times 2. Negative 6 squared would be 36, and the bottom would be 8. What is 36 over 8 when we reduce it? Isn't that 9 over 2? Okay. So we would have to add 9 over 2 to the other side of the equation, too. Okay. And then if I do the same thing here, b squared over 4 times a, for the y's, that would be 4 over 8, which would be 1/2. So that means I would have to add 1/2 to the other side. What is 1/2 plus 9/2? 5, thank you very much. And 5 plus 45 makes the other side equal to 50, right? That's what this is. Now, I don't need to worry about the rest of that crap because they're not asking me about the center. What are they asking me about? The radius. And how do I take this equal to this and find the radius? I take the square root. That's really what we were getting at here, okay? But I always complete my square with the b squared over 4a because, well, for one, there's no reason that I need to factor out 2's and look for. I don't need to do all that stuff, okay? I'm not looking for the center. Have a wonderful evening. We will be here next week. We will not be here the following week. We're skipping February 11th for math, and we will do that last class on March 3rd. I put it on your Google Calendar and sent it to all of your email addresses. We'll be here next week, though, so see you next Tuesday for math. Oh, thank you so much. Any more calculators? Calculators? Calculators. Hear ye, hear ye.